Hi guys, good evening. It's Doc Kyle once again. And tonight we're going to talk about erythrocyte metabolism and membrane structure and function. So, we will talk about how your red blood cell produces ATP and where does it use it. Remember, your erythrocyte metabolism doesn't have a mitochondria. So, it cannot use an oxidative process to form ATP. It relies mainly on anaerobic processes like your glycolysis. And from that glycolysis, we will derive multiple other chemicals that will aid in its function. So apart from that, remember that the job of the erythrocyte is to carry your hemoglobin everywhere in the body through tight blood vessels, the splenic sinuses. So it relies heavily on the structure and the function of its membrane, because the membrane is what gives it deformability, and deformability means its ability to change shape to different needs or different calibers of blood vessels, and its elasticity, by which it returns back to its original shape. So glucose enters the red blood cell via transmembrane protein GLUT1. So GLUT1 is present in most of cells, most red blood cells rather. So this just freely passes through. There is no ATP needed. But the red blood cell needs to convert it pa to ATP. So it uses the anaerobic pathway, your Embden-Meyerhof, remember this, EMP. So glucose metabolizes glucose to pyruvate. Why is it that there is still consumption of 2-ATP? So, ang EMP nimo, your Embden-Meyerhof is it's a very inefficient way to produce ATP. Why? Because you need to pay first 2 ATP to produce just 4 ATP. Meaning your overall gain is just 2 ATP. Unlike in your oxidative process na mas daghan jud ka og ATP na ma-produce for more little na capital, So remember, your overall gain in their Embden-Meyerhof pathway is just 2 na ATP. So we will talk about where this ATP will be used, So the first usage of ATP that we discussed is of course your Embden-Meyerhof. It needs to put in ATP first. So like in life, you need money to make money. So another pathway that derives itself from the Embden-Meyerhof pathway is your Hexose monophosphate shunt. So you need this to produce your NADPH. What is NADPH for? So your NADPH reduces oxidized glutathione. So what does this do? Glutathione is a very strong antioxidant, So if it's an antioxidant, meaning it reduces oxidation of your ROS or reactive oxygen species, or what we call free radicals. Free radicals can directly damage the cell membrane and the proteins of the WBC. So example So given that free radicals can destroy your cell membrane and your proteins, meaning your red blood cell is now very susceptible for what we call hemolysis. Usually this is a type of intravascular hemolysis. Or sometimes there is protein coagulation within, or protein polymerization inside your red blood cells, and once it passes through the spleen, pitting will occur, meaning napaakan tong inclusion, and then we will now have bite cells. So the main function of your glutathione, this one is your glutathione. It will reduce your hydrogen peroxide No, hydrogen peroxide is a type of free radical. So the most common type of free radicals are your superoxide, no, and your hydrogen peroxide. So kato, superoxide, ozone, and hydrogen peroxide kanato imong mga free radical. So in nucleated cells, grabe kay na sila makadamage og DNA. So we all know that UV light can cause oxidative ionizing changes. So kato, and then it sometimes UV sometimes can convert your oxygen into your free radicals, thereby also damaging your DNA. So anyway, going back, your glutathione is needed to neutralize this, but it needs to be in a reduced state. What is reduced mean? So meaning wala siya extra, wala po siya na oxidized iya, no? So the enzyme that is in charge of reducing your glutathione is what we call G6PD. No? So your glutathione reductase. Your glutathione reductase is in charge of reducing your glutathione. The enzyme that is the one that will reduce your glutathione reductase or will lead to the reduction of glutathione reductase via the formation of NADPH is what we call your glucose 6-phosphate dehydrogenase. Now, if you have this wala kay glucose 6-phosphate dehydrogenase, then your glutathione reductase won't act as efficiently. Thereby, it will not reduce your glutathione. It will lead to increased proliferation of polymerized hemoglobin inclusions, no, leading to a very bati na RBC. Eventually, patyo na lang na siya sa spleen, kaya di naman niya, bati naman siya. It can no longer do its function because it's lost its deformability because it has lots of inclusions. Eventually, it will undergo hemolysis. So, kanitong ginatawag nato na glucose 6-phosphate dehydrogenase deficiency. No? So, going back, glucose 6-phosphate deficiency is the most common enzyme deficiency, no, that will lead to hemolysis. So, kato, mag-lead siya sa hemolysis because there is a lot of inclusions na due to the denatured and polymerized na hemoglobin. So, kato, need na to og NADPH na ma-produce sa imong glucose 6-phosphate. Okay. So, this is your Embden-Meyerhof pathway. Sorry. Dili na ko makadraw while in Zoom. So, this is your Embden-Meyerhof pathway. So, it starts with the hexokinase. Don't worry guys, dili na ko mo ipa-memorize dyan sa exact na ng flowchart because, like I said, we are now in hematology. And we will focus on the clinical aspects and how that affects the function of your red blood cell or your blood cells in general. I want you to remember that hexose monophosphate shunt is the one in charge of reducing your glutathione because it is where your NADPH is shunted to, no? So another pathway is what we call your methemoglobin reductase pathway, no? This one over here. So we will talk about what's up with methemoglobin. Basta, methemoglobin reductase is where reducing your so like I said earlier, diba, hemoglobin composed of heme plus globin. In your heme there is iron, which is in the ferrous state, and protoporphyrin 9. In methemoglobin, your ferrous iron is converted into ferric. No? So this happens spontaneously sometimes, but we have this methemoglobin reductase pathway na in charge to reduce the ferric to ferrous. What will happen is, inefficient na imuhang hemoglobin to bind with oxygen. So you will have bouts of hypoxia. Ito. So this one. So iron, Fe3 na siya guys, dili na siya 31. Fe3, methemoglobin is reduced to ferrous. So kani siya. What will happen is your ferric na iron, it's not very good. It's not very good in binding oxygen. So kani over here, if you're gonna look at over here, 64% out sa tanan imong hemoglobin composed of methemoglobin, and you're gonna see the patient has a blue tongue, bluish iyang tongue ug lips, meaning hypoxic siya, decreased ang iyahang oxygen, no? So atong management ng methemoglobinemia is giving methylene blue and ascorbic acid because they are antioxidants, no? Or they reduce the ferric to ferrous. Next kato. So kato ha. So ferric na imuhang iron sa imong methemoglobin. Then here gihatagan na siya methylene blue ug ascorbic acid. So basig malibog mo ani ha kanina part. So this is just the function of your methemoglobin reductase pathway. And then we have your Rapoport-Luebering shunt. This is where you make your 2,3-BPG. So what is 2,3-bisphosphoglycerate, no? So 2,3-BPG is a compound that it's a molecule that decreases oxygen binding from hemoglobin, no? So mas freely siya mo let go. Easy dissociation of oxygen. So hemoglobin na siya gunit na oxygen, no? Dikita na siya 2,3-biphosphoglycerate, ma-release na tong oxygen ion. Okay, so why is that important? Because if your hemoglobin carries your oxygen so tightly na di na let go, then your tissues will no longer have oxygen. Nasa hemoglobin lang tanang oxygen, and the red blood cell is now defeating its purpose for existence, no? I know. Your hemoglobin is now defeating the purpose of its existence, no? So kato di ba i-carry o release man dapat niya ang hemoglobin. Kato na defeat ng purpose sa hemoglobin. So pag dili niya ma-release dayon ng hemoglobin, meaning if dili niya ma-release dayon ng hemoglobin, dili makuha sa imong pinkies, sa imong mga fingers, sa imong mga toes ang oxygen, mag-hypoxia dito, no? So 2,3-BPG is quite important, especially sa layo na part sa imong circulation, no? So I think we talked about the three major pathways, no? So what will happen in 2,3-BPG? Instead of earning additional ATP, you will use the ATP that you have consumed here to form 2,3-BPG. Just goes to show na priority jud sa imuhang red blood cell ang iyang function rather than survival, no? Or timpla-timpla lang jud na siya. So function first before survival, kay willing man siya to let go of the precious ATP to produce 2,3-BPG instead of forming more ATP. Ito. So the Rapoport-Luebering shunt generates 2,3-BPG and enhances O2 delivery to the tissues. So kato ha. So that's the purpose of your Rapoport-Luebering shunt. Now we're gonna go to the structure of your RBC. The RBC membrane is a lipid bilayer, no? So meaning anong lipid bilayer? So we're gonna look at, it's not just a lipid bilayer, so it's phospholipid bilayer, or phospholipid bilayer is a better for me a better term because you're gonna remember it more. So what are phospholipids? Phospholipids are just lipids with a phosphate lipids with a phosphate group, no? So meaning their membrane has a what we call phospholipid head, hydrophilic head kanisha, and a hydrophobic tail. And since it's hydrophobic, they will stick together. Kaning mga hydrophilic head nimo, they will immerse themselves in a aqueous or watery solution like your plasma and your intracytoplasmic fluid. No, mao na siya. So phospholipid bilayer jud na imuhang mga membrane. It's not just the RBC. I think it's all membranes of all of all cells in the body. The membrane is semi-permeable, meaning what is semi-permeable? So semi-permeable simply means in your RBC membrane, it's charged mango. There is a charge in the membrane. So ions cannot freely move inside because there's a charge. But water, since it's small, it can freely go in and out the RBC membrane. So that, and proteins, because they're large, they can't go in. Labi na lipids, no? So that's what that's what semi-permeable means, no? It's selective lang ang iyahang pasudlon. It's a semi-permeable selective membrane. So this is a continuation of 2,3-BPG, no? So kato. So we talked about this. Nasaag lagi na siya. Anyway, 2,3-BPG binds to the globin, like I said earlier, binds to the globin chains. So we have 4 chains of your hemoglobin, of alpha, beta, beta. So it binds in the middle, imo 2,3-BPG, forcing the heme to release it, no? Release the oxygen. So, mo nang meaning. Interior cavity of the hemoglobin tetramer to stabilize it in the deoxygenated state. No? Meaning, it's tense. So, deoxygenated state, we have multiple terms for that. It's also known as the tense state or low oxygen affinity. R-tout, T state, TUT, meaning tight. That's what our oxygenated state means, no? Opposite ni siya sa deoxygenated. Pag bind sa 2,3-BPG, release ang oxygen. Ana lang na to sa yun, no? So we have our hemoglobin dissociation curve. So walay 2,3-BPG. This is our oxygen pressure, no? Oxygen saturation. But since nag-add ta og 2,3-BPG, this dissociation curve will now shift to the right, no? So what does that mean? What does this table mean, no? So table na lang sa tabi for ana. So we're gonna zoom in. So this is the oxygen saturation, meaning pag oxygen saturation, this is kanang pila ka hemoglobin ang nagagunit og oxygen, no? So this is the pressure. So pila ka hemoglobin ang nagagunit sa oxygen. Ang imong y-axis and your x-axis is your partial pressure. So kato. So if mag-add kag to 3-BPG, it will now shift to the right because mo decrease ang percent oxygen saturation nimo, no? Meaning mas release siya. So any shift of the hemoglobin dissociation curve to the right simply means the hemoglobin won't hold tight, no? So mao na ang mnemonic. Shift to the right won't hold tight to the oxygen. And then if it's shifting to the left, no? If wala kay 2,3-BPG like this one over here, like wala kay 2,3-BPG over here, then it won't let go. So shift to the right, won't hold tight. Shift to the left, won't let go. Nakato. So we have another table, kaning carbon monoxide. So it binds 220 nakabutang din but I think it's better to say just 200. No? We're gonna talk about that later na lang. So kato. So the RBC membrane phospholipids are asymmetrically distributed, and phosphatidylcholine and sphingomyelin predominate in the outer layer. So this is phosphatidylcholine. So this is your phosphate na kung ginaingon, no? Biphosphate layer nimo, mga phosphatidylcholine, phosphatidylinositol, no? So outside, common good imo ang sphingomyelin and your phosphatidylcholine, no? Common jud na siya. You also have your glycolipids, which are your antigens and your receptors. And then inside is your phosphatidylethanolamine and phosphatidylserine. So, basta ka na remember this, phosphatidylcholine and myelin sphingomyelin ang sa gawas. There is a time when phosphatidylserine will now go out, no? Sa gawas na siya. And that is what we call senescence. That's what we call senescence. Pag senescent ng RBC, it is now a signal for it to be phagocytized. Pag tigulang na siya. No? Because what happens when the RBC is now old, no, it doesn't have any more proteins or ATP. It's not efficient enough to make proteins that will repair or maintain this membrane. That's why ma-flip out na ning phosphatidylserine. And that is a target of your macrophages, phosphatidylserine. No? So we also have cholesterol, no? Kani sila. What is cholesterol? Cholesterol adds membrane rigidity or structural rigidity to the, meaning mas gahi siya. Because cholesterol is not a chain, no, it is a solid molecule. Unlike your fatty acids and your phospholipids, they're chains manggod. So kung butangan mo mga cholesterol, mugahi siya or more rigid ang iyahang membrane. So enzymatic plasma to membrane exchange maintains the RBC. So we have what you call your kaning acyltransferases, no? ALCAT. Mga acyltransferases. So lecithin cholesterol acyltransferase, your ALCAT. If this enzyme is gone or if there's a problem in your ALCAT, there will be abnormalities with the concentration of cholesterol and phospholipids. There will be now kanang what we call there is a ma-mess up na ang ratio between your phospholipids and cholesterol. Therefore, there will be what we call acanthocytosis and target cells. I'm gonna show you what target cells are. Target cells. These are your target cells. This happens when there is a problem in the proportion of your cholesterol to phospholipids. And these are your acanthocytes. No? So that's what you call your spur cell. No? Na sila mga tagas. Laipod ng Burr cell na to, no? We're gonna talk about that in the future. So, RBC transmembrane. Meaning transmembrane protein, they traverse the entire membrane. They traverse the entire membrane. No? So, these are your transmembrane proteins. No? So, transmembrane proteins are critical in the ankyrin complex and the actin junctional complex to provide vertical and membrane support and to connect the lipid bilayer to the underlying cytoskeleton. So okay. So good tani kay medyo medyo complex, no? Hindi siya complex, guys. Mindset lang ta. Kita mo ani kaning mga lawa-lawa, no, like spider webs, that's your glycoproteins. No? So this GPC, Kel, and Duffy are your what we call blood antigens. We will talk about that in your blood banking. So your ankyrin complex, kani sila, your ankyrin complex and actin junctional. What they do is they provide ana na support. So what does ana na support mean? Meaning they limit the stretching of your RBC membrane. They're just maintaining it at its phospholipid bilayer. If you have any problems with kanang mga vertical na membrane support, then your RBC will now no longer have will have reduced vertical support, meaning it will become like this, a sphere, no? Because remember, dili ideal ang shape sa imuhang RBC. Meaning, what I say, it's not ideal, it's not natural, no? It really needs to hold its shape like that, the phospholipid, the biconcave disc, no? It really needs it to hold its kanang shape like that, and it's an active process, kumbaga, because you really need to maintain the protein complexes, kani imuhang ankyrin complex and actin junctional complex, to provide the vertical support na ma-flat lang siya by concave disc. Because if there is any problem or there is any absent protein in that complex, then your overall vertical support will decrease. Eventually, your RBC will now become a sphere. If it's a sphere, it's a big problem because the hemoglobin in the middle can't transfer its oxygen adequately. Apart from that, if it's a sphere, it will have a very hard time deforming into the tight crevices, no? The tight veins and small arteries. Eventually, dili man gud maka-deform ang sphere. Eventually, it will pop, no? It will undergo hemolysis. Kato guys, ha? So that's why importante kay ng ankyrin complex nimo. Next is kane. So the shape and flexibility, like I said earlier, which is essential to its function, depend on the cytoskeleton. The cytoskeleton is derived from the peripheral proteins. So this is your transmembrane proteins, what we call integral proteins. Your peripheral proteins are this one, no? So this also acts a part in the structure, no? So that's your cytoskeleton, imuhang spectrin, no? Alpha and beta spectrin. And then it will form a connection to your actin junctional complex, forming a hexagonal, this one. So this is your actin hexagonal. Tanggalin sa natin. So this is your actin junctional complex, no? So the cytoskeleton proteins provide horizontal or lateral support for the membrane. So what is this horizontal support na pod, no? If given na vertical, wala kay vertical, it will become a sphere or spherocytosis. Pag wala naman po kay lateral, maana na siya, ma-flatten, no? So that's what we call now your elliptocytosis, elliptocytes, no? It has the same problems as your spherocytosis, by which dili na siya ma-deform, kay rigid naman na siya, flat na siya, elliptocyte na siya. It has a hard time passing through the tight blood vessels. Eventually, it will pop also, no? Ito. So this is a closer view. So, hereditary spherocytosis arises from the defect in spectrin and proteins forming the ankyrin complex, no? So I think I labeled it here. So this one, hereditary spherocytosis, vertical support, and then this is your hereditary elliptocytosis. Due to the defects in the cytoskeleton. Basta cytoskeletonal protein defect, that is a problem in your elliptocytosis. So for the last part, this one, RBC cytoplasmic, that's not K1 that's K plus. That's your potassium concentration, no? So 2:1, meaning mas daghan ang potassium inside the inside of your cell. So I want to explain this properly. So we have your sodium potassium pump, no, or sodium potassium ATPase, no. So what will happen is your sodium is inside. It's higher concentration inside. Gamay lang imong sodium outside. Your potassium is inside, daghan concentration, and your potassium outside is smaller. Your potassium wants to go out to achieve equilibrium. So what is equilibrium? Equilibrium is between a membrane, in the context of a membrane bound na equation, na membrane equal ang concentration sa imuhang solute, no, equal. So if the concentration is greater in this side and this side, the excess solutes would try to traverse the membrane to equalize, to get equilibrium. So given that context, na natay basis, so what will happen is your potassium would like to go out, no? Would like to go out because gamay lang ang potassium outside. Your sodium naman, there's a lot of sodium outside. It wants to go in. So your sodium ATPase pump, it pumps potassium in. Okay, in. Sodium out. So akong mnemonic ana kay piso. Potassium in, sodium out. So what is the importance of this, no? So if there is more sodium inside of the RBC, then remember, where sodium goes, water follows. Our RBC will now become fat, no, and big, filled with water. So if dili na to makontrol ang going in of sodium, then we're not gonna control the going in of water, because I said earlier, water can freely pass through the membrane. Eventually there will be too much, and then pop na imuhang RBC. That's what we call osmotic lysis, no? If too much. If there is too little sodium, then your RBC will crenate. No, may mo na siya wrinkly. Both scenarios are very inefficient for oxygen transfer, no? So this sodium potassium ATPase, no? Potassium ATPase, sodium ATPase, and calcium ATPase. Kaning calcium more of lesser degree ni siya, more of potassium and sodium. They're very important in maintaining the osmotic gradient, no? Osmotic gradient. They're very important in the cation balance, no? So kato siya, mo na importance. Membrane proteins are extracted using SDS. SDS page yun na siya na electrophoresis. So SDS page meaning sodium dodecyl sulfate polyacrylamide gel. So basta I think in instrumentation maistoryanin yung electrophoresis. In electrophoresis we have anode and cathode, no? Mag-migrate ang mga charged na mga compound, no? So kato. So this is our ion pump, sodium, potassium, ATPase, no? So this is the normal. Pag daghan kag sodium ug water, big boy. Pag wala kay water kayo, cremated, no? So kato. So thank you guys, no? Thank you guys for listening. So that's the topic. If you have I advise you to read the chapter jud sa book because it's really quite really quite um really quite comprehensive kumbaga, no. But don't worry, I will not ask questions that I failed to tackle. But like I said, you really need to learn most of this because this will form along with the previous topic, this will form your basis or your what we call foundation for your knowledge, not just for HEMA but for medical laboratory science, because there are a lot of things that overlap, no, between the subjects, even in medicine. So unsa tong gitudlo sa kuan ni Doc Ian sa Lover sa una tong medtech pa ko hantod medicine, it still carried me through, no? So thank you everybody. If you have any questions, feel free to PM me. God bless. Good night.